Chapter 12 is on liquids, solids, and intermolecular forces. And we're going to start just looking at what happens to water when there is no gravity. So what happens when you wring out a wet washcloth in space? If you wring out a wet washcloth on Earth, obviously, the water will drop down. What happens when you do it in space? So the video mentions surface tension. It's really cohesion that's causing those water molecules to stick together. Cohesion is what causes surface tension. But the fact that those water molecules are attracted to each other is what's holding them together. And then there's also attraction between the water molecules and the washcloth, which is what's holding them to the washcloth when he moves the washcloth up and down, and the water kind of bounces but still sticks to the washcloth. This one, he's just showing you that the water, it will form a sphere. And again, it's because of attraction of water molecule to water molecule. So I'm not going to show that one. So if I look at the table here, solids, liquids, gases, what do I notice about the density? The density of the gas is the lowest. Now this is water, and water, unfortunately, is like a counterexample to everything else in the world. For water, yes, solid ice is slightly less dense than liquid water. Usually with matter, your gas is going to be the least dense, and then your liquid, and then your solid. But liquid and solid are going to be pretty close to each other, whereas gas is going to be way, 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 way less dense. So this then relates to the volume. Look at these molar volumes. Water's 18 milliliters per mole. Ice, 19.6. Again, that's strange. For water, it's different with most things where the solid would be a little bit less volume than the liquid. But then look at this gas volume, 30.6 liters. It was 18 milliliters as a liquid, 30.6 liters as a gas. So gases have a much, much higher volume because of their low density state. In the molecular view, you also notice, of course, there's not very many gas particles. They're very far apart. Comparing the liquid to the solid, you probably also notice that the liquid is a little bit more haphazardly arranged, where the solid is very orderly. That's pretty common among matter as well. So gases are a very low density state with an indefinite shape and an indefinite volume. This is because the strength of the forces between gas particles is very, very weak. Actually, part of kinetic molecular theory is that gases experience no intermolecular forces. There are no attractive or repulsive forces acting in a gas. Liquid is a much higher density, indefinite shape, so it takes the shape of its container, but a definite volume. The volume of a liquid is not going to change. It has moderately strong forces holding it together. Solids, very high density, definite shape, definite volume, very, very strong forces holding a solid together. So the particles in a liquid are closely packed, but they do have some ability to move around, and this gives liquid some important characteristics. They are closely packed, so liquids are incompressible. That's one important property of liquids. But the ability of the particles to move allows the liquids to take the shape of their container. So if I pour liquids into different containers, they will always kind of spread out and take the shape of whatever container they're in. This also allows liquids to flow. The molecules can move past one another and liquids can flow. However, they do not have enough freedom to escape or expand to fill the container. So this is why we say they have a definite volume. If I have 100 milliliters of water, it doesn't matter what container I put that water in, it's going to remain 100 milliliters. In the gas state, the particles have complete freedom of motion and are not held together. Like I said, gases do not experience any attractive or repulsive forces. They're constantly flying around, as you know from kinetic molecular theory, in random straight lines until they collide with either another gas particle or a wall of a container. We know there's also a lot of space between the particles. So therefore, as we talked about, the molar volume of a gas is much, much larger than the molar volume of a solid or a liquid. Gases are compressible. This is an important property of gases. They are compressible because all you're doing when you compress a gas is getting rid of the empty space between the particles. Gases also expand to fill their container, and they also take the shape of their container because they are freely moving around. So as you can see here, liquids not easily compressed. Those particles are already very close together, whereas gases are very easily compressed. In solids, the particles are packed close together and are fixed in position, but they do have energy. So a gas at 20 degrees Celsius actually has the same amount of energy as a solid at 20 degrees Celsius. The difference is the gas does not experience any forces, so it's free to move around, whereas the solid has very strong forces holding it in place, and that's going to limit the particle motions to just little vibrations back and forth. Of course, solids are very tightly packed, so they are incompressible. And the fact that the particles cannot move around, cannot move past one another, means that solids retain their shape and their volume when placed in a new container. Also prevents the solid from flowing. There are two types of solids, crystalline solids and amorphous solids. Crystalline solids are very ordered and regular repeating patterns. Amorphous solids are more random. Changing the material's state from solid to liquid, liquid to gas, gas to liquid, whatever, is going to require changing either the amount of kinetic energy of the particles or limiting their freedom, or it could be both. So solids melt and liquids boil when heated because I'm increasing the kinetic energy of those particles. They're starting to move around more. But gases, again, are kind of unique. Gases can be condensed by decreasing the temperature, so decreasing their energy, they're moving around less, they get closer together. Or you can actually condense a gas by increasing the pressure. That's most easily accomplished by decreasing the volume of a container. So this is just showing you here, this is a propane tank, and in a propane tank you have liquid propane. That propane in that tank is under very high pressure, and so it is more the pressure as opposed to temperature that is causing that propane to be in the liquid state instead of the gas state.